video is on lift and Bernoulli's principle. Let's start with the broader topic that lift fits into, which is fluid dynamics. Fluid dynamics is the branch of physics that deals with the movements of liquids and gases. This splits into two categories, which are hydrodynamics and aerodynamics. For my project, I will be focusing on aerodynamics, which studies the movement of how air moves around solid objects. Specifically, I will be focusing on airplanes, and more specifically, lift. Airplanes have four forces acting on them. The first is thrust, which is the forward force caused by a motor. Thrust opposes the drag force of an airplane, which is the backward force caused by the disruption of airflow. Finally, there is lift and gravity. Lift overcomes the downward force of gravity and is explained by something called Bernoulli's principle. When an airplane takes off, the air that goes over and under the wing is called the relative wind. This will always be in the opposite direction that the aircraft is moving. Let's look at Newton's laws of motion to see how this makes sense. Newton's first law of motion states that an object at rest will stay at rest. For example, this airplane shown here will stay at rest on the runway unless it's acted upon by another force. Newton's third law of motion states that every action has an equal and opposite reaction. So, if you look back at this picture, you will see that the relative wind is really just the equal and opposite reaction of the airplane moving. This wind going against the airplane is needed for lift. Now let's look into how Bernoulli's principle shows how an airplane is lifted. As you can see, there is a point on the wing called a trailing edge. When air travels towards the wing, it must split and meet back at the trailing edge at the same time. With the way the wing is shaped, there is more distance on top of the wing than on the bottom part of the wing. Because of this, air on the top of the wing must travel faster, and the air on the bottom will travel slower, so that way they will meet at the trailing edge together. Bernoulli's principle then explains that the air traveling slower under the wing will have a higher pressure and push the airplane up. Next, we have an experiment to demonstrate Bernoulli's principle. You'll blow into a straw, and by doing so, you'll be able to keep a ping-pong ball afloat. This demonstrates Bernoulli's principle in that the fast air that you're blowing through the straw has a pretty low pressure, while the surrounding air around the ball has a pretty high pressure. The ball is able to float because it tries to leave the air you're blowing at it, but the higher pressure air surrounding it pushes it back down, so it floats just above the straw.
But how does lower velocity create higher pressure?
Great question. A simpler way to think of pressure is how many collisions there are. When air moves slower under the plane, the collisions will have a greater force and the pressure will be higher. And when air is moving over a plane quickly, the collisions will have a smaller force.